What is shown here is a graph of y is equal to log x to the base 10. The very purpose of showing this graph is to understand the relationship between log x to the base 10 and the number x. What you have to understand is that, as x increases, as x increases, the y value, that is the log x also increases. There is an increase. It goes to the top, it increases. Okay? And it becomes 0, the log x becomes 0 at x is equal to 1, that is at this particular point. And then between 0 to 1, that is the log x becomes negative. But even then, you have to always observe that as x increases, the log x value is always increasing. Is always increasing in this direction. Okay? Okay. But our objective is to analyze this particular statement again in a different perspective that which is different from what we have seen before. Okay. Now what we have provided is this statement. This is the statement which is provided. Okay. Now this statement can be rewritten as in this way, that is, it can be written as log x. It can be written as log x divided by log b. You convert both to base 10. That is, using the properties of logarithm, you are converting this. Now the given statement is greater than p. We have rewritten in this particular format. Okay. This given statement is rewritten in this particular format. Okay. This is using the property that log a to the base b can be written as log a divided by log b. To this base can be any base, but only thing this should be a common base. So this can be to a base z. Then here also we write base z. Okay. Now using that property, this log x to the base b is rewritten as log x divided by log b. Both of the log I have taken as 10 for convenient purpose. Okay. Now this inequality, you multiply this inequality both sides by log b. Okay. But then when you multiply an inequality by a particular number, you have to be careful with the sign of the number. For example, you have an inequality for greater than 3. You multiply with a positive number, the inequality remains the same. If you multiply by 10, you get 40 and 30, which is the greater than sign holds good. Whereas if you multiply by minus 10, then you get minus 40 and minus 30, and which is bigger? This is bigger. The sign has got reversed. When you multiply with a negative number on both sides, the sign of the inequality changes. Fine? So when I multiply this inequality on both sides by log b to the base 10, you have to be careful. Okay? So there are two cases then. When you multiply, you get two cases. Okay? The case 1 will be, you get log x to the base 10 greater than p into log b to the base 10. This is case 1. And you get another case, that is case 2, where log x to the base 10 is less than p into log b to the base 10. Okay. Now this case comes when log b, when this number is positive number. Okay. When this number is positive, then you get this case, and when this log b is negative, then you get this case. Fine? Okay. Now, we have previously seen the graph of logarithm of log x to the base 10. This graph we have seen, log x to the base 10, log x to the base 10 graph we have seen, and we have analyzed that that is always shows an increasing curve. This curve is like that, it always increases. Okay, as x increases, the log x increases, and log x becomes negative when x is bit less than 1. When x is in this range, log x becomes negative. That's what we have previously seen. That means this log b becomes negative when b is less than 1, and when b is greater than 1, the log b is always positive. Okay, we'll just revisit the graph again to make that clear. You see, this is the graph. This is the graph where log x is becoming negative when x is less than 1. When x is in this range, between 0 and 1, 0 less than x less than 1, logarithm is negative. Okay, when the x is greater than 1, that is when x is greater than 1, then from here onwards logarithm is always positive. Okay, now this property we are using in our while solving the inequality. Okay, so now we got two cases. This is the case 1, and this is the case 2. Okay, now let's take one of the cases. Case 1 you take. Let's go ahead from here. Okay, case 1. Now this right hand side can be written as there is a left hand side is log x to the base 10. Now there is a greater than symbol. Now p times log b. Okay, using the property of logarithm, we can write this as log b to the power p. Okay, this we have to understand that it's nothing but log b added p times. You keep on adding log b. Okay, now when you add logarithm, it's nothing but the number gets multiplied. So this can be written as log b raised to p. Now the base remains as 10. Logarithm of b raised to p is p log p. Okay, now you see here you have log x greater than log y form. Okay, when log x is greater than log y, x is always greater than y. Okay, that we have seen from the graph okay, because the graph is always an increasing function. The graph of log x to the base 10 is always increasing. So when log x, suppose that log x is greater than log y, this is log x and this is log y, this height is log x and this height is log y, and if log x is greater than log y, then corresponding its x values also follow the same rule. So here log of x is greater than log y, that means x is greater than y. Here y is b raised to p. Okay, so this is what you get from case 1. Fine. Now let's come to the case 2. Case 2, what we have got is this one. Now this can be written as log of b raised to p, can be written in this form. Base is 10. So here you have log x to the base 10. Now you see here you have a statement between log x and log y. The statement is between log x and log y, where log x is smaller than y. Okay, when log x is smaller than y, then correspondingly you can write that x is less than y. Okay, but only thing that you have to ensure that the base is 10. Okay, now the base is 10, and for the logarithm of base with 10, when log x is less than log y, you can always write x less than y. Okay, so in this case you get x is less than b raised to p. This is the case 2. Okay, so from where we started, this was this is a place where we started. This was our inequality which we wanted to solve. Log x to the base b greater than p. Let me rewrite it again. We started with a statement that log x to the base b greater than p. This was the statement greater than p. Okay, now this means that x greater than p raised to b, that is x greater than p stands for the power, or power p raised to b, base, b stands for base and p stands for power. Now here the equality greater than remains unchanged when b is greater than 1. This happens only when the base is greater than 1. Okay. Now when the base is less than 1, what we get it, x is less than p raised to b. Okay, so this is our conclusion. Now using this statements, then this kind of inequalities of involving logarithm can immediately be converted. But what we have to keep it in mind is this, the base value. When base is greater than 1, the logarithm follows a positive relationship, that is it's always increasing. Okay, whereas when the base is less than 1, it follows another relationship, and that's why we are getting this kind of a property. Okay, thank you.